Alrighty. Okay. Hello, everyone. Let's see that we've got our recording. Yeah, we're recording. Great. So, hi, everyone. Welcome to Debugging Exceptions with Ozcode. I'm your host, Omer Aviv. I am the founder and CTO of Ozcode. And let's get to it. So, today we'll be talking about fixing bugs real quick with Ozcode Production Debugger. How do we become 5x faster at solving production issues? So, brief introduction. My name is Omer Raviv. I'm creator and CTO of Ozcode. I have dedicated most of my professional career to helping developers find out better ways to debug and troubleshoot code, whether that's code that's they've just written a minute ago inside the Visual Studio IDE with our IDE extension. And now in our new product, the Production Debugger, I've really made a huge focus on how do we solve issues when it's out of our hands, right? Literally out of our hands, when our code is already in the QA staging or even production environment and things go horribly wrong. What do we do then? So that's me. And Ozcode, as I've mentioned, we have two products, the Visual Studio extension and now the Production Debugger. And you'll also see us doing some interesting things in terms of making the two work together. And this is what we call production lens. So, and that's sort of the intersection between the two products where we bring production information into the IDE. So what are we going to be talking about today? So this is going to be a very quick to-the-point training session. We're going to talk about dealing with exceptions that happen in our production or pre-production environment. How do we get the necessary information to troubleshoot and understand that information, go beyond the call stack to see what's actually going on? And we'll also address how do we deal with the real world incident response side of things? How do we deal with PII redaction? How do we make sure that we, on one hand, get extremely thorough information, like full fidelity time travel recordings of the code that led up to the exception on one hand, but on the other hand, we remain compliant to the very stringent regulatory constraints around redaction of personally identifiable information. And then to top it all off, we'll also be talking about collaboration and incident response. So how do we work together as a team, the dev guys and the ops guys and the different people on the dev side, to work together quickly to understand root cause and solve the issue as quickly as we possibly can. And that's what we call 5x debugging. So I'm going to skip most of these slides because I want to really hone in on the core value proposition of Ozcode. What we do is essentially we solve the issue of bug reproduction. We make it so that when a bug happens in production, it will be as easy, if not easier, for me as a developer to get information on that bug as if I had somehow magically been able to reproduce the same exact bug on the same exact version of the source code in production. And then all these steps that we need to take to capture, reproduce, understand, fix, and validate becomes so much easier because I'm no longer spending 80% of my time just on the how the heck do I reproduce this thing, right? So I noticed something went wrong. I see the exception that happened. I have no idea how to make that exception happen again because it happened in production due to some very weird set of circumstances that I do not yet understand. Ozcode sort of does away with this problem by just focusing on the fix side and having the computer automate all the rest. So let's jump into the training. When we think about CI/CD and the whole DevOps movement, it's really been about shifting left, right? Bringing more and more of the notifications of or the information, the data stream, the feedback loop of things going wrong closer to the hands of developers. So the idea is that as I write the software as a developer and it moves across the software development lifecycle goes into QA, then into staging, and into production, I want to get better and better feedback loop. I want to get more insights about what I did wrong quickly so that I can fix the issue before we escalate that deployment to production. Then now, what Oscode Production Debugger does is we're shifting left the observability aspect, right? So when we think about observability, we usually think about tools like New Relic, Dynatrace, Kibana, Grafana, all the logs, log analyzers of the world, where we're using it to observe the system from the outside, sort of like white box understanding of the, or black box understanding of the system rather, where we're trying to look at the logs the system generates to figure out what went wrong. And this is no longer the case with Oscode Production Debugger. Oscode Production Debugger turns that around so that we can actually look inside and see what's actually happening in our production environments. The way it works is very simple. We have an agent component that is just like, honestly, technology-wise, it's no different than New Relic, Dynatrace, AppDynamics, Application Insights, all these tools that you're probably already using, in the sense that the way it works is that it does bytecode instrumentation. It changes the code that's running on the fly. Only with Oscode, we're doing it for a completely different purpose. We're doing it just so that we can help you solve bugs and logical errors in your production and pre-production environment, rather than performance issues as the APM folks do. So the way it works, again, we just install the agent wherever it is that our code is running. That agent then reports information out to a production debugging server, and that server can be either on-prem, hosted as a SaaS offering, or in a hybrid model where it's on-prem, but on-prem in the sense that I'm installing it on my own Azure or AWS subscription. And then the different developers, QA, and production support staff can connect to that production debugging server and experience a debugging experience through their favorite web browser. Alrighty, so how does Production Debugger work? Basically, it works in a way that is completely non-intrusive and production ready. And let's break down and understand what that means. So when we think traditionally about remote debugging, so typically in the olden days, you would think that if you had an issue in production or in staging, somewhere outside of your local development laptop, you would be stuck to using remote debugging. And remote debugging is essentially just live debugging an application that's on another machine. But that does not work when you're talking about production or pre-production, because the way debuggers work is you hit a breakpoint, and that breakpoint halts the service, meaning while you're trying to debug one request, the other tens of thousands of requests would immediately stall and time out. So obviously that's a no-go for production debugger, and it's not even really that useful in staging or QA. Then the other approach would be the fork and debug. So these would be your equivalent of tools like Microsoft Snapshot Debugger and Application Insights, or the Google Stackdriver solution, where what you're doing is you're essentially attaching a remote debugger, but that remote debugger isn't debugging the actual live process and causing it to halt. It's using the copy on write technology to say, I want to essentially take a picture of this process at this particular moment in time, and then I'm going to debug that while the real live actual process continues serving many customers. And taking these lightweight memory dumps is very fast. On one hand, it's only 10 milliseconds typically, but it does have a very severe impact on the memory usage of your application. That's why tools like Microsoft Snapshot Debugger, for example, typically limit the amount of snapshots you can take per minute. I believe the default is something along the lines of 5 snapshots per minute or something of that nature. And then what Oscode Production Debugger does is completely different. We approach Production Debugger by leveraging time travel debugging that's using bytecode instrumentation. Again, the same technology that's powering New Relic, Dynatrace, and all of those guys, but we do it in a way that has a minimal impact on the monitored application. So So let's talk about that and sort of drill in on that for a second, because you might wonder, okay, so what you're describing is kind of like dark magic, right? You're saying, I'm gonna install this agent on my production environment. It's gonna allow me to debug it, but in a non-intrusive way. It's not gonna have a performance impact. It's not gonna weigh down. How does that all work? And what the way it works is that we change code on the fly. So when you think about the normal thing that you do, probably 20 to 120 times a day, you compile your code in Visual Studio or JetBrains Writer or VS Code. What you do is, what the compiler does is it compiles the method by just taking a bunch of C# code and putting that out into method metadata and IL bytecode, right? And that's what the compiler does. That's what it's good at. When we try to solve a production issue without a tool like Production Debugger, we are typically just forced to use logs, right? So we go in, we add a log statement, we recompile the code, we check it into source control, we do a quick pull request, we wait for the entire CI/CD pipeline to do its thing until the next time we can actually deploy it to production. Then we wait for the next time the issue actually reproduces. And then finally, we try to actually get enough logs after sometimes having done several iterations of this that we can actually understand the problem. And that just means that there's new instrumentation, right? That's what logging is. It's just very, very slow logging. It's slow instrumentation, right? What Oscode does is it adds that instrumentation on the fly, right? We take the method, we take the bytecode of the method, we add our own instrumentation using the agent on the fly. And then what we do then is we use the bytecode manipulation technique to dynamically rejit that method. So it's changed on the fly. And because it's changed on the fly, we can very easily turn that instrumentation on and off without even thinking about it. All right. So that is also the explanation for when we ask, so how can this work without, totally messing up my production environment with terrible performance delays if you're suddenly instrumenting my code? The way Oscode Production Debugger approaches performance is that we have a cap of a 3% CPU overhead on all the instrumentation. And because instrumentation happens dynamically, we take the original bytecode, instrument it, we can also reverse it and put it right back where it was. So the Oscode Production Debugger uses a technique of self-throttling. It's constantly monitoring to analyze the performance overhead of its own instrumentation, and then scaling that instrumentation on and off to maintain the maximum of 3% CPU overhead. Okay, I think we understand what the technology is, but let's see now what the technology actually does, right? That's what we're interested in. We're here to learn how can this actually help me debug my exceptions in C# code that's running in production. So what I'm going to do now is I'm going to install Production Debugger on an agent that's running inside my Azure service. So installing an agent is very easy. I'm just going to create a new application. I'm going to call it Demo for Webinar, for lack of an imaginative name. And then I'm going to choose where I want to install the agent on. So in my case, since I'm using Azure, I'm going to do Azure Windows, and I'm going to do Azure App Service because I'm running a website on Azure. And it's telling me getting started is as easy as 1, 2, 3. That's friendly. It says I need to install and configure the Oscode site extension, restart the web app, and then just go. So that's easy. So let's look at what that all actually looks like, okay? So I'm going to go in to the Azure portal. Everybody loves this portal. So many blades. I'm going to go in here and hit extension. And then I'm going to go in and add an extension. When we go and add an extension, we'll see after this thing loads that there's an option called the Oscode Production Debugger. So really the Oscar Production Debugger, if you're working in Azure using the platform as a service offering, it's as easy as going into this Azure Marketplace thingy, finding Oscode, the Oscode extension here, and then just adding it right here. And then the next thing we need to do is we just need to give it the token, the Oscode Production Debugger token for my particular application. So we see that we got our token right here. We can just grab this guy, copy it over to the app service configuration, and the configuration value for Oscode token, put in this guy, like so. Hit OK, and then save, and we'll be golden. Okie doke. So what I've done is I've configured my app service to use the Oscode Production Debugger site extension. What that means ultimately is that we now have a website that's monitored by the Oscode Production Debugger agent. When we have a service that's monitored by the Production Debugger agent, what will happen for us is that it will automatically monitor for exceptions. So now that the website has restarted, let's see an exception in action. So in this case, we have the normal eShop on Web demo from Microsoft, which they like to use to demonstrate .NET Core applications. And of course, we've added a bug here, and that bug has to do with a buy two, get one free sale. So in order to show you the bug, I'm going to show you what the customer did. They decided they want to buy this swanky black sweater. They hit add to basket. They decided they want to take advantage of the lovely buy two, get one free sale. So they updated the count to 2, hit update, and unfortunately, nothing good came out of that. I mean, we did get the notification that we're going to buy free items for the price of 2. But when we actually hit the checkout button, oops, sorry, not the checkout button, got that wrong. We hit the update button, and then the customer ended up deciding that they don't want this t-shirt, and they chose to update to 0 so they can go and buy a different t-shirt. They hit update, and nothing good came out of that at all. So essentially, you can see this sort of stalled, and then they got an HTTP 500 error. And really, that customer is probably not going to buy anything from us ever again. So now let's go into Production Debugger again. And it says that success, the agent is up, and we can start debugging. So we have one agent connected, and it already found an exception. And it's telling us that it's currently capturing. So again, the way Production Debugger works is that, excuse me, the first time an exception happens, we just take a note of it, and we start the instrumentation process. And then once that happens, we wait for the second occurrence of that same exception. So if we make that exception happen one more time, it will turn its state from capturing to captured. Wow. And now, when it's actually captured, we can, when I click in the exception, I can see the call stack. I can see all the same things that I would have been able to see in an error monitoring tool. But I can also go in and debug. And when I actually go in to debug this exception, I see an enormous wealth of information, right? I can see the call stack and the actual code that triggered the exception. And I can see all the local variables for every particular moment in time here. So this is really just the equivalent of having a dump file, right? And I instantly see the code. I didn't have to do anything. I didn't have to actually do all the nasty work you have to do it to analyze a dump file to get all the code, all the local variables, and I can just peer in and understand exactly what the state was at the moment that the exception happened. But this is only where the magic starts. The real sort of showstopper here, or the real magic moment, begins when we go into talking about time travel. So if you notice, Osgood is telling me here that this snapshot only contains the primary debug information, but if I want to get more information on this particular exception, I can request a time travel snapshot. So I'm going to do that. I'm going to start the recording. And then what happens then is that the next time that this issue occurs, like if we go in here, and once again, cause the bug to reproduce, what will happen is that Oscode is now recording full time travel recording of this exception. What that means is that we analyze line by line and essentially give you the same exact experience if you had magically been able to reproduce it inside Visual Studio and just start stepping through the code. So we see that the exception has turned to become fully captured. And then when we go in and look at it, it becomes a lot more colorful. And if you're familiar with the Oscode Visual Studio extension, you'll recognize some of this UI, right? We see that every expression that was false is painted in red, like this if statement returned false, so it was painted in red. And then the actual content of the if statement, the actual branch, is de-emphasized for me because we didn't actually execute it. And then every expression that is true is highlighted in green. So what I see here is that I can immediately analyze the problem and I see, okay, so the reason this happened is that when I went and implemented the whole buy two, get one free sale, I did a pretty good job of implementing the logic for incrementing the count, but not such a good job when I did the logic for decrementing the count. And that's how we turned out with this mistake of saying, oh, we're gonna buy a -1 t-shirts and then, or sweaters, and then down here, inside of the third-party NuGet that I'm using to do analysis, I got an argument out of range. Pardon my brain. Argument out of range exception, and we can see again this visual language of Oscode is very clear and concise in showing me exactly what the code did, right? I don't have to step in the debugger. I can just read it with the visual indication. So I see that this expression returned false, but this expression returned true. And then because we had a short circuit evaluation here, the second expression wasn't even evaluated. And that's why we ended up throwing an argument out of range exception on new quantity. Now, this visual experience of seeing exactly line by line what happened also allows you to understand state changes. Like, for example, here the new quantity variable. When we were at line 9, the value of this variable was 0. But when we got here, it was already a -1. So we can see how things change over time. And this brings us to this notion of collaboration. The thing that's, to my mind, very transformational about this technology is that it enables a GitHub pull request style model for collaborating with your colleagues, right? Today, we all have an ebb and flow of just going about our day, getting a new pull request, reviewing, leaving feedback, sending in a pull request, where we've sort of maximized and optimized our flow as developers of how we can churn out new code through pull requests using social coding, right? That's what GitHub brought to the table. But now with Production Debugger, we can suddenly start talking about social debugging. So when I am forced, maybe I get a PagerDuty notification at 2 in the morning and I'm forced to deal with it, I can just send this link to the Oscode Production Debugging session to my colleague, and they would, again, see the same things that I'm seeing, right? They would see the exact code flow that led to that exception right in front of their eyes, along with all the other information that is relevant, such as the HTTP request information and the logs. We call this the perfect bug report. So for example, if we look at this post request, you can see that I can see the headers, the form, and if this was a post request that had a JSON or XML content, I could also be able to see that. If I had a SQL query, I could see the contents of the SQL query. I can also see the logs, and this is the last 1,000 logs, log entries that happened right up before the exception. And I can also filter this down to see only the logs that are relevant to this particular request. So huge amount of information here. And then we can take that one step further by allowing for instant collaboration. Like, for example, I can say, hey, and I could mention my colleague Idan, who was originally supposed to do this webinar, but I'm filling in for him. But I'll go ahead and let him know that I solved the bug for him, right? So I say, hey, Idan, I think the issue has to do with this -1 here. So I'll say mention variable, which came in as a negative number, even though the original value was, and then I'll go and add something from the top here, like, I don't know, like, I guess this one. What do you think? Ta-da! Now, what I just did there is I employed point-in-time links. So I put in a reference for this very line of code, this moment in time in the program's execution where new quantity was -1, even though a moment before it was 0. And then I also referenced an earlier point in time where it came in as free. So using this technique of point-in-time links, I can refer Idan to different points in time in the program's execution. If you were here for our last webinar, you'll know that we also support trace points across microservices. So I can also use this collaboration feature for showing Idan things that happen in microservice A that led to bad things to happen in microservice B, which later caused an exception in microservice C. So this notion of full fidelity collaboration inside a production debugger suddenly allows us to be extremely productive, to work as a team, to understand and gain a consensus about what is the root cause of the bug and how do we best go about fixing it in a way we just didn't have before. And it has all the pluses of doing a pull request, right? Like, for example, we don't have to be in the same room. We don't have to be in the same time zone even, and we can still have this magical level of collaboration. Okay, so that was a little bit of collaboration. I'll show you how deep the collaboration goes. We can actually even turn and show here that we can give you point-in-time links to variables that are deeply nested inside the collection. So for example, if I send this link out to my colleague, they will see this local variable that I've highlighted, even though it's nested deeply, deeply inside the inside this very complicated object graph. So again, I can just go link to values that I see inside the code editor, but I can also leave these point-in-time links to things that happen deep inside the locals variable, and the animation will highlight to my colleague this exactly what I meant. And likewise, if I find a log entry that I think is really important, like I say, oh, here we're updating the quantity of item 2 to free, I can go ahead and create a point-in-time link for that. So point-in-time links come in two variations for easy collaboration. I can mention this variable, as you saw, and then that will mention it inside the collaboration panel here. But I can also just copy this link. So Production Debugger supports this notion of deep linking. So I can take this link and then just send it using Slack or Microsoft Teams or WhatsApp, or I could actually attach it to a bug report on Azure DevOps or Jira. And then my colleague will immediately see that it scrolled down and shows me exactly and highlights the exact line of logs that I had wanted my colleague to see. So that was the notion of deep, deep linking. Now, let's talk about redaction. This is the last glamorous side of dealing with software nowadays, is that we're all under the careful eye of the regulator, which for good reasons tries to make sure that we're not leaking people's personal sensitive information. So Production Debugger was actually built from the ground up to support extremely stringent regulatory constraints. So we've talked about that already a little bit when we talked about the on-premise model and how I can use the Production Debugger and install the Production Debugging server wherever I'd like. So for example, I can install it on-prem. I can even do that in a network that's completely cut off from the public internet, or I could install it on my cloud subscription on Azure or AWS, but do it inside, deploy the production debugger on my subscription so that it's mine, and it can even run under my VPC so that it can be completely restricted on the IP level, that nobody from outside my organization can even touch that data in any way. So that's one aspect, but another even more interesting aspect is the notion of PII redaction. So sensitive information is redacted automatically, and let's look at how that works. So when we're looking at this notion of collaboration, we will also take a look at another exception that I might want to collaborate with my colleagues on, right? So what happened is that when the customer finished dealing with the first bug and they actually have a shopping cart, and they go and they actually want to check out their items, so first thing I need to do, I need to log in order to check out. And I'm going to put in my fake details here. And this could be, if this was not a demo, this would be my very sensitive credit card information. So I'm going to just do this one, which is a great credit card number. And I'm going to put in my actual name here. So please do not abuse these stringent very private details. And I'm going to hit complete purchase. And again, so I can't believe this website, nothing works, right? I tried to add an item, didn't work. Now I'm trying to actually give them money and pay with my credit card, still doesn't work. And then I'm gonna go into production debugger and see that we immediately got this exception. It's already capturing. And then when I, again, production debugger turns the instrumentation on, when the next time the exception actually occurs, when I refresh the page, I see that it's captured. Now I can actually debug it, and I see redaction, right? If we look here at the state property, it tells me something really interesting. It tells me the value is personally identifiable information and was redacted. You can change redaction settings to show it. Now, Oscode uses role-based access security. So I'm currently logged in as an administrator to the system. That's why I get this message. If I was not an administrator, I would just get a message saying this value is redacted. And if you would like, you can contact your administrator if you think that's wrong. So really cool tech. And then if we add the full capture aspect to it and reproduce this issue one more time, you'll see that the redaction is really all over the place, right? So if I go and now that the exception is fully captured, go and debug it once more, we see that state will not only be redacted here in the locals view and inside any of the items they're in, but it will also be redacted on the actual code editor. But now I'm seeing that some things here were not redacted, which is bad, right? So for example, you can see what city I grew up in and what country I'm from. So that's very sensitive information because you could possibly be used to identify me personally. So very bad, very bad. So luckily, Oscode Production Debugger uses this technique of PII redaction on multiple layers. So if we go back to look at the system architecture slide, you can see that the first thing that happens is that PII redaction happens on the agent side, right? And that makes sure that the information that we stipulated needs to be redacted does not even leave the production machine itself. But then I can always go in and fine-tune the redaction settings based on the needs of my organization further, and that happens on the production debugging server. So that's extremely comforting because I know that even if we finally realize that we need to add more things to the redaction settings, we can do that after the fact. And because Oscode Production Debugger never allows customers or developers to actually download the dump or anything of that nature, the entire debugging experience is done through their web browser, that means that A, we can redact after the fact and nobody will be exposed to that information ever again. And B, we can maintain and can enjoy the fact that we now have a full audit trail of knowing exactly who saw what, right? Which developers were exposed to which debugging sessions and what variables and so on and so forth. So that gets us all set on the compliance perspective. And there's quite a large myriad of ways that we can configure these redaction settings. So if I go and click on this button that is inviting me, or I just go into redaction settings here, can also be accessed for here. You can see that there's quite a few different approaches we can use. So we can redact based on the regular expressions approach, or we can just use identifiers. So this would be things like password and PWD, and every possible way you can make a spelling mistake in the word password, etc., etc. But we could also filter out inside entire classes or namespaces. So if I'm in the healthcare industry, I might be filtering out things that I have to do with DICOM or patient names or any identifying information about the patient, and so on and so forth. But the system does ship right out of the box with some really good sensible defaults for all the normal suspects, right? Like CCV and SSN and user and email and password and all of those things. So that was a brief intro to PII redaction. And I think that's about everything we wanted to talk about today. So do we have any questions, dear audience? Any questions at all? Feel free to hit me up. If you do not have any questions, I can also tell you that we are happy to take your questions at any point in time. You can just reach out to us at support@ozco.com, and I'll be smiling at your emails and very happy to hear your feedback and very happy to help. So I see that we don't have any questions come in. So with that, I'll say thank you very much, everyone. It's been a privilege to get to talk to you today. And I'll see you on the next webinar. Bye-bye.